So does this mean that the sun is warm or cool? So I'll go back here. You guys can take a look. So there's our sun. It's a class G yellow star. Is it warm or cool? What do you guys think? It is continually cooling as it goes through its life cycle. But yeah, it's a warm star. It's not hot. It's not a blue star, so it's warm. It's not as cool, though, as, let's say, Betelgeuse is. So it's a warm star. If the sun were significantly hotter, a lot of the liquid water that we have here on Earth would evaporate. So the temperature of the sun is actually pretty important to life on Earth. Okay, so inner planets, also called terrestrial planets, which we covered in our warm-up, they are dense and rocky, and again we have Mercury, Venus, Earth, and Mars. So these are the inner planets. They are very close. One of the cool things that you will come across in your lesson, if you haven't read the lesson already, is a map where they start in New York, and then they map out the planets going across the United States. So you can see the relatively compact distance of these inner planets. The inner planets are relatively close together. That's why we can't even see their orbits here in this picture. And then as you go further out, they are much further away from each other. So when we talk about the terrestrial planets, the inner planets, they are also relatively close together. Inner planets, much of this is review. Start with Mercury. So Mercury is solid and it's covered with craters. It has almost no atmosphere. And it's very, very hot because it's like this little rock that's just getting baked right next to the sun. So it is the smallest of the 8 planets. So all the planets together, Mercury is the 8th largest. Venus. Typically when we look at Venus, we see its incredibly dense atmosphere. So if you were to look up, especially in the summer, in the evening sky, because it stays light later in the summer, right? We have more hours of daylight because we're tilted towards the sun. If you look up in the sky around sunset, you'll see this really bright star. That's actually probably Venus. Venus is incredibly bright because of its really thick atmosphere that totally hides the surface of the planet. So if you were to look at Venus through a telescope, you would not see the surface. You couldn't see ground or rock. You would just see that really dense atmosphere. So Venus is about 75% the size of Earth, so it's a bit smaller than Earth. And then, of course, Earth is the 5th largest planet and 3rd from the sun. So the reason that we have liquid water is that we're in that distance where we're not so close like Mercury that we're just getting totally baked and all of the water is evaporating. And then we're not further away like Mars to where it's significantly colder. So this liquid water on the surface is unique to the Earth. Some scientists think that there is liquid water out there in the solar system. When I was a kid, they told us there is no water anywhere else. That's why there couldn't possibly be life anywhere else in the solar system, really. They said, you know, you need to have liquid water in order for life to occur. But they have now hypothesized that there are some moons, especially around Jupiter and Saturn, there are some moons and dwarf planets that may have liquid water below their surface. So when they first looked at some of these dwarf planets and moons, they saw just ice on the surface, kind of like a snowball. And so they thought, oh, it must be solid ice. Well, now they think because of geothermal activity beneath the surface, right, but it's not liquid water. So yes, if conditions changed and it warmed up enough, like if it had more of an atmosphere to trap in heat, it could be liquid. But right now, there's no liquid water as far as they can tell. As far as they can tell. That's why there's always that, what we know right now. Like I said, this has changed in like 20 years from when I was younger. And they're like, nope, there's no liquid water anywhere else, nothing that we could find. So there's, can't remember if it's Ceres, which is in the asteroid belt, which is a dwarf planet. And then one of the moons of Jupiter, it's got this like icy crust on the outside, but because of geothermal activity, so heat from within the core of that moon or dwarf planet, they think that it's warm enough to where it would basically be, grab my drawing tool, like this sheet of ice on top, and then a warm core down here, so that in between, so this would be like the core of whatever that object is. So let's say the moon of Jupiter. So that makes them think that maybe in between, kind of sandwiched in between, there could be liquid water. So the surface is so cold that it's ice, but because of this heat underneath from like volcanic activity, they think there may be basically an ocean trapped under that surface of ice, which was really